Hello ladies and gentlemen, and welcome to Harding's Chemistry, where today we're going to be having a look at empirical formula, what an empirical formula is, and also how we can go about calculating empirical formula with examples. So first things first, what is empirical formula? Well, the empirical formula of a substance is the simplest way we have of expressing a formula, and we're familiar with these in our everyday lives. If we think of table salt, we would know that table salt has the formula NaCl. But we also know that an ionic lattice contains many billions of different ions. But when we look at the simple ratio of ions there, that gives us the empirical formula NaCl, which is obviously a lot easier to use than Na several billion to Cl several billion. So how can we go about calculating empirical formula for molecules, atoms, ions, substances that we have in chemistry? So here's an example for us. Analysis shows that 0.6075 grams of magnesium combines with 3.995 grams of bromine to form a compound, and now it's given us some atomic masses that we can work with. And it's asked us to determine the empirical formula of this compound. Firstly, let's pick out any pertinent information. So we've got here the mass of magnesium as well as the mass of bromine, and as the question's given us some relative atomic masses, those are the ones that we'll use in this question. I always find it best to lay out empirical formula calculations in a very specific way, and I'm going to show you the way that I'd lay out an empirical formula calculation as we go through this. So firstly, I would create two columns, and I'd write at the top of these columns the atoms which each one is going to be concerned with, and I'd follow that by writing down the mass that I'm going to use of each element, and these are given in the question. So here we're going to write in our mass of magnesium, which is 0.6075, and here we're going to write in our mass of bromine, which is 3.995. And this method of laying it out is just so that any examiner or anyone marking my work can see clearly what it is I'm attempting to do and find out where to award my marks. Now the next stage in this is to work out the number of moles that we have, and to do that we need to divide the mass by the molar mass, and as you can see from the AR, if we use this to generate our molar masses, that means that we need to have magnesium here divided by 24.3 and bromine divided by 79.9, and this gives us amounts in moles, or N, of 0.025 for magnesium and 0.050 for bromine. So it's all well and good, but these aren't yet whole number ratios. So what we do next is we divide by the smallest amount of moles, and hopefully we can see in this case that that is magnesium here. So we're going to divide each of these by 0.025, and that will give us our final whole number ratio, and that, as we can hopefully see, gives us the ratio of 1 to 2. So for every magnesium ion in this compound there will be 2 bromide ions. The question is still not finished. We need to turn this into a chemical formula, and to do that we just use this ratio to decide how many of each we're going to have, and as we've already said, we have 1 magnesium to every 2 bromines, which gives us MgBr2. So we've followed the steps neatly laid out. So on this following question, see here, the analysis of a compound showed the following percentage composition by mass, and it's given us the percentages here of sodium and oxygen, and it also wants us to calculate the empirical formula. Now this example is slightly different. We don't have any masses for our elements, but what we do have is a percentage. So we'll just pretend, for the sake of argument, that the overall masses we're working with total 100 grams. And that means that we can say we have 74.19 grams of sodium and 25.81 grams of oxygen. And from there, we calculate the empirical formula exactly as we did above. Firstly, laying it out nice and neatly so that anyone marking the work knows what it is we're trying to achieve. We're going to have our sodium and our oxygen columns, and we're going to write down the mass. We divide the mass by the molar mass to calculate moles before finally finding the ratio of each and writing a formula. So the mass of sodium here is, for our intents and purposes, 74.19. The mass of oxygen is 25.81. And what we're going to do now is we're going to divide by the atomic masses, or the molar masses of each. So we're going to divide by 23.0 here. We're going to divide by 16 here. And this gives us amounts in moles of 3.266 for sodium and 1.613 for oxygen. Now, to determine the ratio, we're going to divide both of these by the smallest amount of moles that we have. So we divide oxygen by 1.613 moles and sodium by 1.613 moles. And this then gives us a ratio of 2 to 1. Yet again, we're still not finished, so now we need to turn this into a chemical formula, and we're going to take our sodium here, make it Na2, to oxygen to give the final formula Na2O. So, in conclusion then, empirical formula is the simplest form of a chemical equation using a whole number ratio. So, simplest form of a chemical formula. And we use the example of sodium chloride to demonstrate that. We've also seen how we can work it out by, first of all, working out moles by doing mass divided by molar mass is equal N. And then if we divide by the smallest N, the smallest amount in moles, we can determine the ratio between the different elements present before finally generating a formula. So, I hope this has been helpful. Stay tuned for more videos. Thank you for watching.